Hello everyone, section 5.3 for Algebra 2. Let's see, first thing I need to go through with you guys is make sure that you're okay with the idea that when this symbol, which is generically called a radical, is missing a number right here, it's the same thing as a square root. These are identical symbols. So if you wanted to be, I don't want to say lazy, but if you wanted to I guess be efficient and not write the number, you don't have to. This is the same thing as a square root. They're identical statements. The problem becomes later on when we start doing cube roots. If you just leave this, that means a square root. If you intend it to be a cube root, the number has to be written in there. So when it's a 2, it's optional. When it's other than a square root, it is not optional. For now, we're just going to work with square roots. One of the things to understand is that when the power on a number inside matches the root, they cancel out. So this symbol will cancel that symbol, and you're just left with 5. In other words, it just pops out. So the square root of 5, or square root of x squared, just comes out as x. Backing up to this one, this is exactly the same statement. To help you see it, it's the same thing as the square root of 25, and you guys all know what the square root of 25 is. It's 5. But just giving you evidence that this symbol cancels this symbol, and the number just pops out. So this symbol cancels this symbol, and they pop out. So when the power matches the root, they undo each other. When the power isn't big enough, when it's 5 to the first, nothing can come out. It stays what it is. It doesn't simplify. It doesn't reduce. Bringing together another idea is when you have a product of roots, you can bring them together into one root, which is then the square root of 16, which you guys know is 4. But what I'm just illustrating here is that when you have a product, you can bring it together into one root. Likewise, when you have one root, you can think of it as a product, and you can break it apart into 2 separate roots. There's no motivation on why in the world you'd want to do this, but we're going to use this idea on the next page. Also, when you're multiplying, to go back to something we've done before, and the bases are the same, and you're multiplying, you add your exponents. So that's 3 to the 5th plus 6 to give you 3 to the 11th power. Using this idea, you've brought this together as a product into one single base with an exponent. You can break apart something that has an exponent on it into multiple different ways. I could break that apart in 5 to the 6th times 5 to the 1st, as long as those two numbers add to the original. You could break it apart into 5 to the 5th times 5 squared, or you could break it apart 5 to the 4th times 5 cubed. Again, you're in charge of how to break this apart. I'm just illustrating that here you had a product, you brought it together to write it as one single answer. If you have a single number to a power, you can break it apart multiple ways. These all mean exactly the same thing, as long as their exponents add to the original power. Using that example we did before, I would love it if I could break this thing apart so the powers match the root, so these individual pieces would pop out. Again, the goal is to reduce this, or to simplify this. To do that, I'm going to rewrite 5 to the 7th as 5 squared times 5 squared times 5 squared, which is 5 to the 6th, times 5 to the 1st, gives me 5 to the 7th. Doing it this way, this power matches the root, so it's going to pop out. This power matches the root, so it's going to pop out. This power matches the root, so that one's going to pop out. And I'm left with 5 to the 1st on the inside. Now, if this is confusing you seeing it like this, I'm going to break it apart this way. The square root of 5 to the 7th, I'm going to break apart just like it was up here. I don't know why I'm writing so crooked today, uphill. I'm going to break it apart as 5 squared times 5 squared times 5 squared times 5 to the first. And if you need to see it this way, there's no reason that you have to do it this way. I'm just illustrating a point. You can break these apart into separate roots. These are all square roots. When this power matches the root, those symbols cancel out and you just have a 5. Those symbols cancel out and you just have a 5. But this one isn't big enough. This power is smaller than the root, so it has to stay. So you're left with 5 times 5 times 5, which is 125 square roots of 5. Okay? When you have one that looks like this, you can do the same thing. I'm going to break these apart to get to 4. Whoops, it's not a cube root. It's a square root. I'm going to break these apart so the power matches the root. 5 cubed could be 5 squared. Again, I'm choosing a square so it matches the root, times 5 to the first. 11 to the fourth is 11 squared times 11 squared times x squared times x to the first, y squared. Again, these have to add to the original power. And I'm choosing squares because it's a square root. Times z to the fifth is z squared times z squared times z squared. Oops, one too many. Whoop. I was going to go z squared. Z to the first. Okay. Things that where the power match, they're going to pop out. This one, the power matches, so it pops out as 5. That one's too small, so it's got to stay put. It only has an exponent of 1, so it's got to stay there. Both the 11s come out because they're both their powers match. This one's going to pop out. That one's got to stay put. Both of these come out. It looks like I'm going to run out of room. And both those z's come out. Sorry about that. And a z and a z. But this z has to stay behind. So I've got 5 times 11 squared times x times y squared times z squared times 5xz. And notice I usually am not writing the 2 that's here because, again, they mean the same thing. So you'd multiply this out. So that's 121 times 5. Yeesh, 121 times 5. So that would be 5, 10, 1, carry that, 605. So 605, woo, getting carried away with the 5, or the 0, I mean, x, y squared, z squared, square root, 5xz. Okay? Now here, I'm going to show you doing it that same long way, then I'm going to show you guys a shortcut that makes it a little bit faster, because writing these things out, that can be a bit of a drag. So there's always a more efficient way to do it. So this exponent is a 1, so I just have to leave it. 3 squared, it already matches the power, so I'm just going to leave it. 5 cubed is 5 squared times 5 to the first. X squared, it already matches, so I'm going to leave it. Y cubed would be y squared times y to the first. Z to the fifth, as we saw on the previous page, z squared times z squared times z to the first. Anything that has a power that's matching the square root pops out. So the 3 is going to pop out, the 5 is going to pop out, the x squared is going to pop out, the y squared is going to pop out, and both z's are going to pop out. So if you have both of those z's popping out, you get a z. Whoops. All right, let's try this again. Sorry about that. Ay, caramba. Okay. The 3 when it pops out is 3. The 5 when it pops out is 5. The x squared when it pops out is x. The y squared when it pops out is y. There we go. And the z when it pops out is z. This z when it pops out is z. And the other ones are still left inside. 2, 5 is 10, y, and z. So when all is said and done, you get 15x, y, z squared, square root 10x, y. Now, I think you would agree writing this out like that is a bit of a drag. It takes time. It gets messy. It's large. So let me try and show you another way that groups them in powers of 2 that matches this root that's a little more efficient. It involves dividing the power, I'm going to say it backwards, let me try and say it forwards, dividing the root into the power. As you've seen, this isn't big enough to come out. 2 does not divide into 1. Okay, it doesn't fit. It's not big enough. So this is going to stay put. 2 to the first. I'm only writing the 1 to illustrate a point. 3 divides into 2 once, and that's the exponent on the outside. 3 divides into 2 once, with no remainder, so there's nothing left inside. 2 divides into 3 once, with a remainder of 1. 2 divides into 3 once, with a remainder of 1. 2 divides into 2 once, with no remainder, so there's nothing inside. 2 divides into 3 once, with a remainder of 1. 2 divides into 5 twice, with a remainder of 1. So your answer, 15xy z squared square root 10yz. And it matches the same thing over here. Okay? Less writing, less work, more efficient. Now, you're not going to have any in your homework that are this big. I just think sometimes showing you the biggest ones helps illustrate what it is that's going on. These are the ones that you're going to have in your homework. And let me show you how to do it. You're going to prime factor. Prime numbers are 2, 3, 5, 7, 11, and so on. They're numbers that can only be divided into itself and 1. I'm going to start with the smallest prime number, 2. 2 divides into 24 12 times. 2 divides into 12 6 times. 2 divides into 6 3 times. And these numbers are the prime factors of 24. 2 times 2 times 2 times 3. So this is the square root of 2 cubed, because there's 3 2's, times 3. I'm going to put the 1 there to illustrate the point. 2 divides into 3 once, with a remainder of 1. 2 won't go into 3, so nothing else comes out, and that 3 has to stay put. So this simplified is 2 square roots of 6. 48, start with 2 again, 24, that's a 4, 2, 12, 2, 6, 2, 3. 1, 2, 3, 4, and 1. So this is the same thing as the square root of 2 to the 4th times 3 to the 1st. 2 goes into 4 twice with nothing left over, and 2 does not go into 1, so it's just 3 has to stay put. So you can leave it like that, or you could write 4 square roots of 3. Again, the 2 is optional. You can put it there or not put it there. 54, I'm going to start with 2 again. 27, I'm going to move on to the next biggest prime number, 3. 9, 3, and 3. So 54, the same thing as the square root of 2 times 3 cubed. 2 will not go into 1, so that has to stay put. 2 goes into 3 once, with a remainder of 1. So 3 square roots of 6. 162, 2 and 81, 3 and 27, 3 and 9, 3 and 3. So I've got the square root of 2 times 3 to the 4th. Again, the 2 won't go into this 1, it's a square root. 2 won't go into 1, so that 2 has to stay put. 2 goes into 4 twice, so 3 squared. Or you guys could write 9 square roots of 2. Okay, so that would be your final answer, either one of these. Okay, the last thing to show you guys is you're going to get some problems like this. To remind you what I did in the first page, these can combine together into one root. 2 times 8, which is 16. And you guys don't have to prime factor this. I'm hoping you recognize the square root of 16 is 4. If you're having trouble seeing it, yes, you can prime factor it. So that's the same thing as the square root of 2 to the 4th. 2 goes into 4 twice, nothing left over, which is 4, just like you got doing it the other way. Same thing. 3 times 12 is 36, which I'm hoping you guys recognize as 6. When you have coefficients outside, they multiply together. So you get 10, then those come together, 8 times 10. So you have 10 square roots of 80. And then you prime factor this, 2 and 40, 2 and 20. Let's see, 2 and 10, 2 and 5. So you have 1, 2, 3, 4, and 5. So that's 10 square roots, 2 to the 4th, times 5. It's a square root. 2 goes into 4 twice. So you have 10 times 2 squared, and the square root of 5 has to stay put because that exponent isn't big enough to bring anything out. So that's 10 times 4 square roots of 5. So you have 40 square roots of 5 would be your final answer. Okay, and as you can see, it's the end of the first part of 5.3.